This film, from March 1966, shows the Air Force Eastern Test Range at Cape Canaveral in Florida. Looking north at the Cape from an aerial view along the ICBM or heavy launch area, here are launched the Atlas, the Titan, and the Saturn, America's heavyweight missiles. To date, the largest booster ever fired from the Cape has been the Titan III-C, a triple-barreled missile with 2.4 million pounds thrust. The United States entered the new field of space exploration by developing missile boosters that would be a deterrent to any potential enemy. Since missiles and space exploration were brand new to us, there had to be a great deal of experimentation. Here, a Jupiter, developed by the Army, has an early test. As you can see, a guidance malfunction occurred and the vehicle starts to veer off course. The engines can be seen gimbaling or turning to correct for the erratic flight. The use of photography at this phase of testing pays off for the engineers, as we can see from the slow motion sequence. The missile is to be doomed by the range safety officer, but not before it has sent much valuable information by radio back to the ground telling us what went wrong. To the average person looking on, the test was a failure, but this failure provided vital information allowing the trouble to be corrected, and we can be sure this type of malfunction did not happen again. Jupiter went on to become an operational weapon system located in several NATO member nations in Europe. Thor, like Jupiter, had its problems. On this short flight of 26 inches, a switch cut off all fuel to the engines. The vehicle lost power and fell back through the launch ring. Despite the destruction, this launch stand was back in use 6 weeks later, and a successful flight was made. Through the use of optics, telemetry, and visual observations, problem causes can be pinpointed and remedied. Atlas First D Series. At ignition, explosive bolts are supposed to fire, separating the hold-down A-frame from the launch ring. The bolts in this launch failed by a fraction of a second, causing the thrust chamber to come in contact with the frame on liftoff. This caused a rupture in the thrust chamber. Raw fuel poured through and caused a destructive fire. The pre-range safety officer waited until the last possible moment before taking destruct action. The propellants of the Atlas are refined kerosene and liquid oxygen. Titan I explosion. This Titan I explosion on the launch stand was caused by the vibration of the engines. The primer cord in the destruct package exploded. This ruptured the fuel tanks and the missile was destroyed. For some unknown reason, no telemetry information was received. The viewing of this same film sequence in slow motion revealed the trouble. Titan II. Air Force specialists ready a Titan II for launch. Here is a close-up of the engine at ignition, which clearly shows the connecting lines ejecting from the engine section. Notice the transparent flame pattern at launch and during flight. Here we see the value of our long-range camera. The first stage burns out, and second stage ignition occurs. Final separation of the instrument package and the ballistic arc is followed to impact. Polaris explosion. The Navy's Polaris missile also took to sea. However, the second stage inadvertently ignited prematurely and took off by itself. The range safety officer had no recourse but to destroy the flying second stage. This was done by blowing off the nose cone, creating negative thrust. The missile then fell into the sea. The first stage finally burned out on the stand. Polaris sublaunch. As development continued, the day arrived for a crucial test, the first launch from the underwater tube in a submarine. 40 miles off the coast, this historical event took place. Here is the latest test of Polaris. As you can see, even on this day, escorts were not only above, but directly in the launch area below the surface. Compressed air is used to push the Polaris to the surface, and then it ignites. This test was a complete success. More advanced models of the undersea weapon are continually being tested. Minuteman. Taken to the launch area by this mobile erector, the Minuteman is raised into the vertical and then slowly lowered onto its launch ring. Crews prepare the missile for the precise moment of launch. We pick up the count, and then, as the 0 mark is reached, a rush of flame and smoke rises from the silo. This is immediately followed by the famous smoke ring. Then the Minuteman itself is flying the full test course. This missile is operational with Strategic Air Command and is deployed in hard sites throughout the country. Explorer 1. This is the first U.S. satellite launched into an Earth orbit. This missile is a modified Redstone with an instrumentation package. The spinning tub is a cluster of rockets to give flight stabilization. The TROS weather satellite was another space first for the world. Note the TV cameras and solar cells which convert the sun's energy and keep the vehicle active. This orbital weather eye has contributed much to plotting storms heading for various areas of the world. The Blue Scout was never intended as a weapon. Rather, it is used for deep space probes and to check special material used in re-entry vehicles. This missile is relatively inexpensive and performs as would a heavy booster doing the same job. This slow-motion engineering sequence is a prime example of the coverage required for such a launch. Note the tabs being pulled away as the bird lifts off. There fire small rockets that impart a spin to the Blue Scout missile. The spin acts similar to a gyroscope. It tends to stabilize the missile. As the Thor Able Star is ready for launch, there are many last-minute checks that have to be accomplished. Finally, there is ignition, liftoff, and the bird is on its way. This test has an inflatable balloon that will expand in space after the nose cone separates and the package is loosened. Here we see the cone separation and the actual inflation. This balloon is still orbiting in space. It has been used to bounce signals from one point to another. This was the forerunner of the Telstar satellites we know today. Atlas Agena Moon Probe, a vehicle that sent back the excellent pictures of the moon, is a basic Atlas booster with an Agena second stage that performed without flaw. Here are the pictures taken. The first is an animated view of the moon. The sequence is the exact one transmitted back to Earth. Centaur, first of a new concept in missile configurations. Atlas Centaur is a basic Atlas booster with a liquid hydrogen engine as the second stage. This vehicle will be used to launch a Surveyor satellite to the moon for a soft landing before we send the three-man Apollo flight there. The actual shots of the moon's surface. Man in space. This was the last flight of Project Mercury. Millions of people all over the world listened to or viewed every step along the way. This sequence speaks for itself with astronaut Cooper getting into his spacesuit, arrival preparation, insertion, launch, and track. As the free world completed the Mercury project with single-man flights, our country moved ahead with the Gemini flights, 2 men in space. Pilots James McDivitt and Edward White are in the suit-up trailer getting a final physical prior to departing for Pad 19 and their launch vehicle. A quick ride to the launch stand, a short ride to the capsule area, insertion, and the final wait for liftoff. The EVA experiment, or extra vehicle activity, was a great achievement for this nation and all the free world. Astronaut White steps from, or rather floats free, of the capsule for his historic walk. Throughout the world, recovery crews stand by to pick up the men. Approximately 10,000 military men were involved in the recovery phase of these flights. Another historic first in manned flight, the rendezvous, or the meeting in space, a phase that is a must for future programs if men are to return from the moon. This sequence shows that man is able to meet and dock in future trips to and from the moon. Saturn. One of the free world's largest boosted missiles, the Saturn scored an historic first. 1 million pounds were lifted into the air by 1.5 million pounds of thrust. The missile was 163 feet in length, and the flame pattern stretched for more than 300 feet. The instrument package that was put into orbit in January weighed 18 tons. 10 complete successes have proved the booster for future manned launches. Through the eyes of the onboard cameras, we see the staging of the missile and the ignition of the second stage engines. Titan 3C is a triple threat among the missile vehicles launched from the Cape. It consists of two outboard solid engines with a Titan II as the core, or middle launch vehicle, and develops nearly 2.5 million pounds of thrust. It has had 3 successful flights to date. After all pre-launch checks are completed, the vehicle is launched. As a missile powers through the atmosphere, notice the shock pattern at the forward ends. Approximately 60 miles in space, the ROTI camera, recording optical tracking instrument, captures the burnout and stage ignition of the core. From the cameras later recovered from the ocean, we see the solid boosters burn out and fall away to the ocean. The Cape can be seen clearly at the bottom of the frame. Titan 3C will be the vehicle to send the manned orbiting laboratory into space for periods for as long as 1 month. We like to think this is a typical day's activities at the Air Force Eastern Test Range. This is the end of our film, but in our exploration of space, this is only the beginning.